Welcome to the third edition of Math Mind Lecture Series. Today we are going to look at topics in chemistry. Electrolysis. Electrolysis is an essential part of chemistry where we talk about ions in solutions, what happens to them, and how they act inside solutions. So we are going to begin immediately with cells. Cells. The things we will talk about in this series will be, let's talk about cells. We talk about, of course, what electrolysis is. We talk about other terms like electrolytes, electrodes, anode, cathode, and so on. So we'll look at these terms so that anything we'll be talking about, we'll take them sequentially. Okay, first thing we'll talk about is cell. What are cells? Apart from the biological term cell and cell in other parts of chemistry, what is a cell? What are cells? In this cell, we are talking about chemical energy. Chemical energy. So cell has to do with chemical energy. Chemical energy, either converting chemical energy to electrical energy or converting electrical energy to chemical energy. So it's a cell that does that. We have wet cell in terms of the batteries we use that are made up of acids, lead acid batteries. Those are examples of wet cell. Then the dry cell, the normal batteries we also use in our torches. Some of them contain ammonium chloride and carbon and all those things. They're also dry cells. So cells are mediums through which electricity is generated from chemical energy. Those cells can also accept electricity in order to get charged and now dispense the electricity after being charged in order to be discharged. So those are cells. I've talked about wet cells and the dry cells. Okay. The next thing we'll talk about is the main term here, electrolysis. Electrolysis, let's talk about it. Electrolysis deals with two words. Electrolysis. Electrolysis deals with two words. Here you have the one coming from electricity, and then you have the one that means to break up, break down, to sever, that's an English word. To sever, yes, something. So breaking up and breaking down, we'll use them interchangeably here. So what does electrolysis mean in these aspects? Electro, coming from electricity, and lysis, to break up or to break down, simply is the break up or breaking down of a compound into its constituent elements by passing electric current through it. The breaking up or breaking down or lysing, severing a compound into its constituent elements by passing electric current through it. So that is electrolysis. Most times the compounds are ionic compounds. Most times we talk about ionic compounds in electrolysis. Ionic compounds. And what are ionic compounds? Those compounds which on dissolution in water they are split into the positive and negative ions, making them up. Ionic compounds. Remember when you did something about bonding, you talked about ionic bonding, which also means electrovalent bonding. Good. So those compounds are mostly soluble in water, and once they dissolve in water, they are separated momentarily into the positive and negative ions. For example, when sodium chloride dissolves in water, the ionic theory says this is what it looks like inside water. Sodium ions are separated from it, and then you also have chloride ions moving around in the solution. So these are in electrolysis, when sodium chloride, molten sodium chloride is involved, we are expecting to get back sodium as an element and chlorine as a gas. That's what electrolysis does. So let's talk about electrolytes. An electrolyte is a solution of an ionic salt. An electrolyte is a solution of an ionic salt in water or in any other solvent that will allow its ions to move about to conduct electricity actually. So mostly it is water that we're talking about. So an electrolyte is a solution of an ionic salt, of a salt, which will allow the easy passage of electricity through it. That's an electrolyte. Electrolyte, a solution of a salt which allows electric current to pass through it. That's an electrolyte. An example is, of course, a solution of sodium chloride, brine, a solution of any other ionic salt that is soluble in water will form an excellent electrolyte. Not all things that dissolve in water are electrolytes. Sugar cannot be an electrolyte. Sugar solution cannot be an electrolyte because it can't split up inside that solution into negative and positive ions. So electrolytes have to split up into negative and positive ions to become what they are and to do the work they are expected to do. Electrodes are mostly metals or solids that conduct electricity on their own, that can also let current pass through them. Electrodes are good conductors of electricity. So, for example, carbon can be a good conductor of electricity in graphite. Carbon can be a good conductor of electricity in graphite, but not in diamond, not in carbon black, but in graphite. Iron, Fe, iron, just metals that conduct electricity can act as electrodes. And now, electrodes are divided into two. Inside the electrodes are normally found in electrolytes. They normally work in electrolytes. When electrolysis is involved, electrolytes are normally in electrolytes. So let me just draw something that looks like something. Good. So if we have an electrolyte inside here, this basin, these are the electrodes. These are metal electrodes that could allow current to pass through the whole system. So this whole system can be supported if the electrodes. Now, in the electrodes, you have what you call the positive electrode and the negative electrode. In the electrodes, we have the positive and the negative electrodes, which could be anode or cathode. So, in electrolysis, the anode is a positive electrode. While the cathode is a negative electrode. What happens at the anode is often oxidation, and what happens at the cathode is often reduction. So oxidation takes place at the anode, reduction takes place at the cathode. So anode, positive electrode. It is called anode because it attracts anions. Its negative ions go to it, while positive ions go to the cathode. That's why it's called cathode. It attracts cations. Anode, positive electrodes attracting anions. Cathode, negative electrode attracting cations. So let's get that before we continue. Okay. Like I talked about, there are electrolytes, very many of them. Substances which can dissolve in water into negative and positive ions or charges are electrolytes. Others which can dissolve in water but not into negative and positive electrodes are non-electrolytes. So they are not needed in our studies now. Sugar solution is one of them. When it is dissolved in water, it can't conduct electricity, so it can't be used as an electrolyte. So an electrolytic cell is a cell which uses electric current to break down molecules, to break down compounds into their subsequent atoms, subsequent elements. That is an electrolytic cell. It's a cell which breaks down compounds into their constituent elements using electricity. When electric current passes through them and you have your electrodes, they can break down the compound into their substituent elements. So let me take, for example, when sodium chloride is involved, actually, let's take electrolysis of molten sodium chloride. This is what actually happens. Of course, this takes place. Oh, sorry. This will always, sodium, because it's a metal, for it to form an ion, will release electron. But in electrolysis, this sodium ion will gain electron to become sodium atom, while chloride ion will lose an electron to become chlorine atom. So this is what happens actually here. This is not a spontaneous process because it requires the use of electricity to push it, to let this reaction, to keep it going, to even start it. It is not spontaneous. It's a non-spontaneous process where sodium ion, instead of losing electrons, the ion will gain electron and become sodium atom. And the chloride ion will have to lose the electron it already has to become chlorine atom. So it's a non-spontaneous process. Someday we will talk about spontaneity, but just remember that if something is spontaneous, it doesn't require an external force to start it or to keep it going. But here, this can't happen on its own except if electricity is involved or is passed through the solution. So let's talk about ionic theory. Ionic theory, I've said something about it earlier right now, but we will say a little more about it. Arrhenius, when Arrhenius was defining an acid, he talked about protons, hydrogen ion as the only positive ion in solution, as the definition of an acid. At some point also, he conducted experiments on electrolysis and explained that when an electrolyte, when a compound dissolves in water, the ions, just like I said, the ions, and separated into the ions are constantly in motion inside the solution. They are all around inside that solution. The positive and negatives are free. They're freer to move than when they were in the solid state. So that is so that reactions can easily take place. Then, if you introduce a foreign body there, which can also interact with the ions there, then reactions can take place. So ionic theory is all about ionic interactions, when ions interact with each other. Okay, so that something like inside water containing sodium chloride, I keep using sodium chloride, but not to worry. Any other one can also go into it. If you have sodium chloride in water, now there will be 4 different ions present there. We have sodium ion, you have chloride ion, you have OH ion, and then you have H3O ion. This is hydrogen ion or oxygen ion. These are 4 ions moving around. If any other substance which also dissolves in water and to become ionic also is introduced here, so let's say something about something like calcium carbonate. Let's talk about calcium carbonate, calcium ion, and the carbonate ion. A reaction could take place here because sodium may now, of course, it won't happen right now, but because of these ionic interactions, different reactions may take place here. So that is precisely what ionic theory is talking about. Because of the difference in electronegativity and electropositivity of the elements forming the ions in that solution. So Arrhenius is saying that the number of charges in any given solution has to correspond to the valency of that atom or that group of atoms forming that ion. So that is what, in a nutshell, ionic theory is talking about. And that is what is going to lead us into the core concepts of this topic. So let's make a small table. Let me just give some examples. Electrolytes, cation. We have known what cation is. Cation is a positive ion. An ion is a negative ion. So if you have an electrolyte of sodium chloride, I keep using it. The cation there is sodium ion, an ion is the chloride ion. If you have potassium hydroxide, the cation there is potassium ion, an ion is hydroxide ion. If you have something like I mentioned calcium carbonate, the cation is calcium 2 plus, because calcium has a valency of 2 and it forms a divalent, is divalent actually, and it forms an ion of 2 plus. And then carbonate also is negatively divalent. You can talk about any other. Let's talk about this ammonium nitrate. Ammonium nitrate, the cation there should be ammonium ion and the nitrate ion should be the anion, etc., depending on what we are actually dealing with. Chemically written, Arrhenius is actually saying that if sodium carbonate is dissolved in water, the ions present, apart from the H plus and the OH minus ions, will be Na plus and CO3 2 minus. Of course, if you balance, you have two of these to 1. The ratio is 2 is to 1. So if you have 1 mole of this dissolved in water, inside that 1 mole, you have 2 times sodium ions than the carbonate ions. So that is Arrhenius theory in a nutshell, and the ionic theory, of course, Arrhenius theory in a nutshell. Arrhenius, maybe you wouldn't get the name. Arrhenius, the person that brought about the ionic theory and the acid definition, the first acid definition, or the first definition of acid as the only positive ion when dissolved in water. Okay, so let's keep going. Electrolytic reactions. Reactions in electrolysis are divided into 2 half reactions. They are called half cell reactions. Into 2 half cell reactions coming from redox. They are all redox reactions. Redox means oxidation, reduction reaction. Reduction reactions. So into two half reactions. One of it is oxidation, the other one is reduction. That is what happens in electrolysis. I have said something about it earlier on. Good. This is reduction. This is oxidation. And if you look at these electrodes, you see that the one that will attract positive ions would be the cathode. So the sodium will definitely go to the cathode. That's the meaning. While the chlorine will be released at the anode. That's actually what happens during electrolysis. So you see, the anode is oxidation, while the cathode is reduction. So if you are conversant with oxidation and reduction reaction, you understand what I'm talking about. But if you are not, understand it now. That the cathodic half reaction takes place simultaneously with the anodic half reaction. Both of them are happening at the same time. There can't be one without the other. When the anode is experiencing oxidation, the cathode is experiencing reduction. So you have cathode and anode inside the electrolyte, and they are all working together. So let me draw this to show you the mechanism of electrolysis. This may be the only time I draw this. Now you have the passage of current through let me shorten this here. Good. This is power supply current. You have the passage of current, positive, negative. So you know this is the anode, this is the cathode. Then you have the electrolytes in between. What's actually happening here is that when a DC supply, this is a DC supply, when the switch is put on, what happens is that current will start flowing. And when current flows, the electrolytes will get agitated. The charges will start moving. Positive collects at the cathode. Negatives collect at the anode. Sorry. So you see, let's take for example, what is here is copper 2 sulfates. Copper 2 sulfates. Let's take for example, this is copper 2 sulfates, or copper 2 tetrasulfate, 6 salt inside the solution. It's normally blue. When this starts taking place, you will see copper here. Copper will go here to deposit this salt, while the sulfates ion go close to the anode. So oxidation is taking place here, reduction is taking place here. So I just gave an example of what actually happens when the electric current is passed through a solution of copper sulfate of any other thing you may be talking about. So we will talk about, now I want to talk about the electrochemical series. Electrochemical series, before we talk about any other thing, electrochemical series. Now, I want you to take note of this. This is very important. These are the alkali metals and the ions. Ion 3, stannous lead 2. Then you have hydrogen ion, copper 2, mercury is 1. Oh, mercury 2, argentum, silver, then you have gold. These are positive ions. These ions, I will talk about why they are the way they are. And then we have the negative ions. Talk about the OH minus, iodine ion, the iodide ion, bromide ion, chloride ion, the nitrates. These are the radicals. Before you get the sulfates, very electronegative, and then the highest of them all. See, good. So what have I done here? I have divided this into the cations. Cations are up and the anions are down. The cations so these are the cations. Of course, these are not all of them, but the most popular ones actually. What this is showing is that it's showing that potassium, sodium, just the way it is coming down is what you call the electropositivity is increasing. The ease at which they release electrons. The ease at which they release electrons. And that is also the ease at which ions are discharged. Is our preference of discharge. So what it means is that if potassium ion and zinc ion find themselves in the same solution, which one will be released first? Which one will be preferably released? That is what we are talking about. So as you move down, the ease increases. It is increasing preference for discharge of ion. What it means is that the zinc ion will be released before the potassium ion. And then this also decreasing electronegativity for the anions, and also is increasing the preference for discharge. So I may not be writing well now, but get the words and write. Okay, so what I'm talking about here is that in the anion series, fluorine is always the one with the greatest electronegativity value. We know that. What it means that if fluorine and if the fluoride and the iodide ions are found in a solution, the iodide ion will go first before the fluoride ion. But the fluoride ion is even never discharged at all when the others are there. So look at it. As you come down, the ease increases. If you have sodium ion and lead 2 ion, the 2 ion will go first before the sodium ion. But I want to say something. If you have potassium and sodium together, they are very close to each other. None will actually go first. Other factors will come in to determine which one goes first. That is what we call the preferential discharge of ion. Preferential discharge of ion. And this takes place in electrolysis. So there are two factors, like I have said, there are two factors determining. There are two factors that determine the preferential discharge of ion. One of the factors is preferential discharge of ions during electrolysis. One of the factors is the electronegativity value, where it is in the electrochemical series. We have talked about it. Okay, if it is lower, as for metals, if it is lower, the lower it gets, the lower the metal is in the electrochemical series, the easier it is to be discharged from solution. The higher the metal in the electrochemical series, the harder it gets for it to stay in solution more than the ones that are lower. In the negative ions, the lower the electronegativity value, the easier the ion comes out from the solution. But the higher the electronegativity value, the more the ion stays in the solution. So that is the first one. Okay. The first one, we talked about the relative position of ions in series. Relative position of ions in series. Number 2 is the concentration. Concentration is how much ions are present at a particular time. Concentration of ions. Ions are present at the same time, at a particular time. For example, if we have more, let's say, okay, if we have more sodium ions in the solution than potassium ions, then sodium ions will have to start leaving until they get nearly to equal concentration with the potassium ions. So the more the ions, the easier it is for that species to leave the solution. So that is the second one. The third one depends on the electrode. Nature of the electrode. You know, there are always two electrodes, the negative and the positive electrodes, the cathode and the anode. So the nature of the electrode determines the ones that will leave. For example, in the electrolysis of sodium chloride, if carbon electrode is used, then sodium will never leave. Instead, hydrogen will leave in place of sodium. Of course, that also talks about the relative position of ions. See where sodium is, see where hydrogen is. So hydrogen will leave before sodium because hydrogen is contained in water. That is solution. So for us to get sodium, we don't even have to dissolve it at all. We have to melt the sodium so that it should flow, be in molten state before the sodium goes off. Okay, so that is what we are going to talk about for now. This is electrolysis 1. When we talk about the other part of electrolysis, then we'll see the calculations there. Okay, let's talk about the examples of electrolysis. The first one we are going to talk about is electrolysis of water. electrolysis of acidified water. Now, water on its own is neutral, so it can't be electrolyzed. For it to be electrolyzed, it has to be acidified. A little amount of acid will be added to it so that it can now be separated into ions, positive and negative ions. Now, mostly we use drops of conc H2SO4. So H2SO4 is dropped in the water in drops, 2, 3, 4 drops, depending on the side, depending on the volume of the water involved. Now, when it is dropped in there, it will create ions. The cations will become. So let's talk about it. H2SO4 and water. So the ions there will become H plus, of course, 2 of them, and SO4 2 minus, while water will also be separated into H plus, again 2 still, and OH minus. So the concentrations of this H2SO4, the concentration of these ions here will be low, while this one will be high. Take note of that. So, what happens at the cathode and what happens at the anode? At the cathode, this is the same thing as electrolysis of dilute H2SO4. They are just the same. So, the cations are this hydrogen ion, the anions are there. So, we have 3 different ions there. So, what happens there now at the anode and what happens at the cathode? Now, anode will accept the negative charges, the negative ions. They will all go to the anode. Now, look at our electrochemical series. The negative ions there are OH minus and SO4 2 minus. What happens there is OH minus will be preferentially discharged than the SO4 2 minus. That's actually what happens. This will go off instead of the SO4 2 minus. While at the cathode, of course, the H plus has nothing that competes with it. So H plus goes off at the cathode. And look at the equations here. At the cathode, H plus aqueous plus, we gain an electron definitely to become H atom. And once another one takes place, you have H atom plus H atom. Hydrogen goes off. So at the cathode, hydrogen is released. This is the cathodic half reaction. At the anode, what happens? At the anode, the OH minus releases its electron because, of course, it's non-spontaneous, but that's actually what happens there. When it releases its electrons, it will form just this. 2 of it will come together to form water plus an oxygen atom, which, when the process continues to take place, 2 oxygen atoms will become oxygen gases. So you see what happens here. Water goes back to the solution, but this gas goes off, oxygen goes off. So that is why it is called electrolysis of water. Water, generally now, what you have there is that water will give hydrogen and this. Okay, good. So when this takes place, this is liquid water, and 4 molecules of water will give 4 molecules of this and 4 molecules of this, which in turn will become 2 molecules of hydrogen gas and oxygen gas plus 2 molecules of water. So before we come to this, we have to summarize it actually. That's what will make these things balanced will be 4 electrons will be released. 4 electrons will be released. So this is for water. For another example, let's take another example. Electrolysis of copper 2 sulfate is blue, so I'm using blue. Electrolysis of copper 2 sulfate solution. Copper 2 sulfate, in this solution it is blue in color, and inside that solution you have CuSO4 and water. Cu2 plus and SO4 2 minus. This is H plus and OH minus. These also are the ions present. So at the anode, so let me talk about cathode. At the cathode, where is it? SO4 and OH minus are there. So OH minus is released, preferentially discharged. While at the anode, we have copper and hydrogen. Copper is below hydrogen in that series. See hydrogen, see copper, and of course it is more because copper is more. So let's see, copper is discharged. Because copper is more, it will be discharged, even though they are close to each other. Copper will be more and will be discharged preferentially. So these are two applications of examples actually of electrolysis, and that's where we're going to stop for this one. This is electrolysis 1. We'll come back again for electrolysis 2, and that will involve calculations. Please go through this, and if you have questions, put it down in the comment section. Thank you, and have a good night first. Bye bye.